All right, so let me do a quick little science lesson. And those of you that check this out, hopefully it helps. We're right at the end of the science practices section, I believe. Yeah, yesterday we did some statistics and talked about mean, median, mode, and range. So today I just want to run through some different practice questions, and then we'll probably cut things a little bit short. But we'll just see how much we get. So I'll just go ahead and get started with some of these practice questions. And just as a side note, we've got a couple more weeks of class before we take a couple weeks off, and then we'll return in the summer, starting, I believe, July 1st is our first day back for summer. And so I'm sure classes will look somewhat similar, but I know soon things will be changing in terms of the structure of the classes and what we can offer along with these online classes. So just kind of keep tuned in to the website and make sure you're keep in contact with us weekly, so that when things do change, you hopefully know about it and are ready to take advantage of it. So let's just do some of these practice questions. We'll do the first three since they all deal with this same passage. So I'll go ahead and read the passage, and then we'll talk through some of these. 1543 publication of Nicholas Copernicus's heliocentric, sun-centered, theory of the universe marked a crucial moment in the history of science. Copernicus's theory that the planets revolve around the sun was controversial. At first, many refused to accept that Earth could be hurtling through space. However, we now know that Copernicus's theory was accurate in many ways. Despite its importance as a breakthrough, Copernicus's theory contained a number of ideas that today seem primitive. For example, Copernicus maintained that the planets were embedded in crystalline spheres. Additionally, while Copernicus developed the novel and later widely accepted idea that Earth rotates on its axis, he also believed that the planets orbit around the sun in perfect circles. We now know that the planets move in elliptical orbits. Okay, so first question just asks, which of the following is the main idea of the second paragraph? Okay, so we're looking at just the second paragraph. Trying to basically summarize it or say, what is the main idea? A, primitive astronomers accepted Copernicus's theory when it was first published. B, while Copernicus's theory was an important development, it included elements that are outdated today. C, Copernicus believed that Earth moved around the sun rather than the other way around. Or D, Earth does not hurtle through space. Okay. So, again, we're looking at this paragraph here. So I can pretty quickly throw out D, Earth does not hurtle through space. That is a quote from in here, but it is from the first paragraph, okay? So it's definitely not a main idea of the second paragraph, and the paragraph was talking about the opposite, that Copernicus proved that Earth was traveling through space. So he is definitely not it. And then I'd throw out A, primitive astronomers accepted Copernicus's theory when it was first published. False statement also, they didn't, right? But again, that is something talked about in the first paragraph. They talk about how when it was first published, it was controversial, which means they didn't accept it. So for both of those reasons, it doesn't make sense. So it's either B or C. And just as a quick frame of reference, let's look at the first sentence, because oftentimes, not always, but oftentimes the first sentence tends to be the topic sentence, which tells us what the paragraph is going to be about. And the first sentence says, despite its importance as a breakthrough, Copernicus's theory contained a number of ideas that today seem primitive. Does that sound like one of our answer choices? Okay. What about B? While Copernicus's theory was an important development, it included elements that are outdated. Sounds pretty similar. And C, Copernicus believed the Earth moved around the sun rather than the other way around. First of all, that was never really talked about. And second of all, B just seems to fit better, right? And again, if you go back to the first sentence kind of tells us what the paragraph is going to be about, and that first sentence is essentially restating exactly what B is telling us. So B definitely seems to be the best answer. Okay, number 2 says, which of the following would be an appropriate title for this passage? So this is another way of wording the same question, because essentially the title should tell us what the thing is about, which is another way of talking about the main idea or the topic, or right, the general idea of what the paragraph is about. So it's worded differently. It asks us to pick a title for it, but it's really doing the same thing. Okay, so let's look. A, important landmarks in 16th century science. Doesn't sound right to me because we're only talking about one person. We're not talking about all of science in the 1500s. B, Copernicus, the life of an astronomer. Okay, it is at least talking about Copernicus, so I'm going to leave that one for now. C, the significance and limitations of the Copernican theory. D, the Earth-centered universe. I'm going to throw out D because, again, Copernicus's whole idea was that the universe didn't center around him. That, in terms of his knowledge and his theory, was that everything revolved around the sun, right? So D is wrong. And between B and C, the two that mention Copernicus, which one best sums up the idea of the passage? Is it talking about the life of Copernicus, or is it talking about his theory and what was significant about it and what was limiting about it? And it seems to be more of that, right? So C seems to be the best answer. And the final question on this passage here just asks, which of the following can be inferred from the passage? Remember, both on the science and the social studies test, you need to know a lot of vocabulary, right? Or you need to be comfortable with lots of words, and you should expect to see some words that you don't know. That's just the way it's going to be. You're not going to know every word that you read on the test, and so just be able to adapt and be able to do the best you can, right? So which of the following can be inferred? And again, inferred means what can be implied but not directly, something that can be implied or can be assumed to be true, but it's not something that's specifically stated in the passage. That's what it means to infer, right? A, astronomers now believe that the planets are not embedded in crystalline spheres. Okay. B, astronomers now know that Earth does not move around the sun in an ellipse. Wow, that out. C, all aspects of the Copernican theory have now been disproven. Or D, Copernicus took inspiration from the primitive astronomers who came before him. All right, so I'm going to throw out C first right away. All aspects of the Copernican theory have now been disproven. That's not true, right? There are lots of aspects about the theory that have proven to be true, right? B, astronomers now know that Earth does not move around the sun in an ellipse. When it talks about the sun moving around, or the Earth moving around the sun in an elliptical orbit, it is saying in the very end of the second paragraph that Copernicus actually believed the planets orbited around in a perfect circle, which was then later disproven and shown to see that the planets actually orbit in an elliptical pattern, which is like an oval, right? So for that reason, B is also wrong. So does it seem like the best answer is A or D? And D, there isn't really anything mentioned that even alludes to or implies that Copernicus took inspiration from primitive astronomers. But A does have, it is mentioned And so let's look at it closer. Astronomers now believe that the planets are not embedded in crystalline spheres. So they didn't say that. What they said was, they said Copernicus's theory contained a number of ideas that today seem primitive. For example, Copernicus maintained the planets were embedded in crystalline spheres. So they didn't say that people today believe that's not true, but they implied it by saying, here is an example of something that today seems primitive. And then they gave you this example, but they didn't say specifically astronomers now believe the planets are not embedded in crystalline spheres, but by saying that it is thought of as primitive implies that that is true, or that is the case, right? So A is the right answer. Kind of a tricky question. All right, number 4. Matter is generally found in one of 3 phases: solid, liquid, and gas. A substance can be converted from a solid to a liquid, and then from a liquid to a gas by adding heat. Once the temperature of a solid substance reaches its melting point, any heat added is used to change the solid to the liquid phase. So, while the phase is changing, the temperature of the substance remains constant. Once the phase change is complete, the temperature of the liquid continues to rise. Similarly, once the temperature of a liquid reaches the boiling point, any heat added is used to change the liquid to the gas phase, and the temperature remains constant while the phase is changing. Okay, so the graph, and that's a lot of words, right? But the graph is showing us what the paragraph is explaining, which is that as you add heat, right, the temperature of that substance will increase until it reaches the point at which it changes states, and then the temperature remains constant, and that added heat initiates more and more of that change in states of matter. In other words, if we have a solid, we can heat it up and the temperature will increase until the melting point, and at that point, it can't get any hotter, but what starts to happen is more and more of the solid start to melt and turn into liquid, okay? And it isn't until all of that solid material is turned into liquid that then the temperature starts to rise again. And then once it reaches the boiling point, the same thing happens. Temperature stops increasing, right? Stays the same. And as more heat is added, more of that material changes from liquid to gas until the point when all of that liquid is then turned into gas, and then the whole process starts over again. Okay. So, with that said, we've got this like stair-step graph, right? With the letters A, B, C, D, E on the different sections of the stair, right? If you want to. So the question asks, at which point are phase changes occurring in the graph above? And remember, a phase change is when we go from solid to liquid or liquid to gas. So at which points are we changing states of matter? Okay. A says A and E. B says A, C, and E. C says B and D. And D says C, D, and E. So remember, what it says was that once we reach the point at which a phase change happens, we go from solid to liquid, we go from liquid to gas. Once we reach that melting point or that boiling point, the temperature levels off. So where on the graph is the temperature flatlining or leveling off? B and D. This is representing the point at which solid is melting and turning into liquid. And this is representing the point at which that liquid is reached its boiling point and is turning into a gas. C is the right answer there, B and D. All right, let's do a few more of these. I don't want to go through this big long one here. But let's just do 6 through 8, and then we'll stop, and then I will do some more of these tomorrow, and go over kind of the ones that we didn't go over today. And sounds good. And if you're watching this, again, hopefully this is helpful. So questions 6 through 8 all deal with this paragraph and this graph. Let me zoom in on the two, and I'll read the paragraph, and then we can look at the question. So, the paragraph says, record high temperatures were recorded in numerous Australian cities in the summer of 2012. The chart below indicates current and former temperatures for 7 of those cities. For instance, Hobart's previous record was a little below 41 Celsius, and its current record is a little above 41. Okay, so we have this graph, this bar graph, and it shows us record high temperatures in Australian cities. The dark bars represent the previous records, and the lighter colored gray bars represent the current record. Okay? So we have Cape Naturaliste, Hobart, Canberra, Penrith, Giles, Usea, and Lenora. I don't know if those are how you pronounce them, but you have the previous and current records for all of these different places. Okay? So, number 6 asks us, according to the chart, which city experienced the largest increase from its previous record to its current record? So what do we think? A, Hobart, B, Penrith, C, Usea, or D, Lenora? So basically all we're doing here is looking to see which of these cities has the biggest gap or the biggest difference between the black bar and the gray bar. And it's pretty clear Penrith, right here in the middle, had the biggest increase, right? Because this distance seems to be the greatest between all of these different cities. So it's as simple as that. Sometimes you get a question that straightforward, sometimes you don't. Okay? All right, let's look at number 7. Number 7 says, which of the following cities had a previous record equal to the median of all the cities' previous record? That's tricky, okay? So, here's how I would break that down. Let's look at it closer. Which of the following cities had a previous record equal to the median of all the cities' previous record? But this is kind of a misleading question, because really all it's asking is to find the median city in regards to previous record. So we're not even looking at the gray bars, the current records. This question is only focused on the black or the dark bar, right? And if we look from left to right, I would say that they're in orders. Because remember, if you were in class yesterday when we talked about median is the middle number in a set of numbers, or the middle point in a set of data. Okay? But they have to be in order, from high to low or from low to high. They can't be random, right? But if I look at the dark colored bars, as I go from left, Cape Naturaliste, Hobart, to Canberra, on down the line, I can see that the dark bars steadily go up, 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 up. So they're already in order. So now the only thing left to do is find the median, or the middle. So where is the middle value? 1, 2, 3, 4, 5, 6, 7. There's 7 cities. So it's the one right in the middle, Penrith. Which of the following cities had a previous record equal to the median of all the cities' previous records? Well, it's Penrith. They're representing the median value. That is a silly way to word it, and they make it sound much more complicated than it is. But it's as easy as that. Okay? They're just trying to trick you. They almost tricked me, because I was thinking there was more to it than that. All right. So, Number 8, the last one here, and hopefully you can still read it because I had to zoom out a little bit so that we can still see the graph. But number 8 says, according to the chart, which of the following statements is true? A, temperatures will likely continue to increase. B, temperatures increased 5 degrees or less. C, temperatures increased more than 5 degrees. Or D, temperatures usually increase 2 to 5 degrees in the summer. Okay, so again, we have to be careful here. We can only go off of what the chart is telling you. But A, temperatures will likely continue to increase. That isn't something we can tell whether or not is going to be true based on the chart. Okay? That's an assumption that we could make, but there's not enough evidence in just the chart to say that that's a true state. Okay? So same thing with D. Temperatures usually increase 2 to 5 degrees in the summer. Well, all of the information on here, cities and temperatures of their record temperature. There's nothing on here differentiating between seasons and if things are hotter in the summer. I mean, we know things are hotter in the summer, but the way that that statement is worded implies that each summer things get hotter and hotter and hotter. Or you could take it to mean it's saying that temperatures are only 2 to 5 degrees hotter in the summer than they are in the winter, which either way, this chart isn't showing us anything that has to do with that. So D doesn't make sense. Between B and C, which one seems to be accurate based on the chart, just based on what they're telling you? B, temperatures increased 5 degrees or less, or C, temperatures increased more than 5 degrees. And if we look at the chart, most of these cities seem like the current record barely increased. This is the biggest one, and even that one seems to be pretty close to or less than 5. So between these two, I feel best about going with B because C clearly doesn't make sense. I wouldn't say that they increased by more than 5, right? So we're about 5 minutes short, but I don't want to get into another question. I think I'll save the rest for tomorrow and hope that we've got some more takers for science. So I will go ahead and stop it there and hopefully see everybody again for science tomorrow. Okay, that's all I've got.